Good morning once again to you all. I welcome you all to another presentation on our control system. By the way, today we are going to see the lecture number 21, in which we are going to see one more important example on mechanical translational system. So, to find out the transfer function of the given mechanical translation system, that's what we are going to solve. This is a very important question which has been asked in UPSC examinations also. Let us see the example. It is, you can call it as question number 1. The question is given like this. There is a reference given here. This is the reference given, and for this reference there is a mass of weight m1 is connected with spring constant and then with the dash part. Okay, so this is, it is given F, it is given K1, and upon which force is given F of t. This is your F of t is given here, and there is one more small block of, small mass element is there with mass m2, and these two are connected. There is a common spring constant. We can call it as, it is given K12, K suffix 12, and here the displacement is given as y2. This is displacement is given as y2. Here it is given as y1. The displacement is given as y1. Now, for this question, you are asking to find out, the question is this: write the differential equation. The question is, write the differential equations governing to this mechanical system. Okay, write the differential equation governing to this mechanical system. And second one is, find out the transfer function. Find out the transfer function. Okay, what is the transfer function? The differential equation, I think you already know about it. I already explained you how to write the the differential equation for the given mechanical system. However, I will explain you for this problem also now. Okay, we will write the differential equation. Then coming to transfer function. So what is the transfer function? How to find out, or what is the transfer function? What parameters to be considered in order to find out the transfer function for the given mechanical system? As I already explained in our previous lectures, so here also let us see what is the displacements given. Always in the mechanical system, remember that the displacement is to be considered as output. The second displacement, second in the sense, this is the block 1 or mass 1, this is the mass 2. Obviously you take the second mass element and the displacement of the second mass element, that is nothing but y2. Y2 is the displacement corresponding to the second mass element. Therefore, you have to consider y2 as your output. And what is the applied force? F of t. F of t. So here in this problem, F of t is applied on mass element m1. So it is there is no it can be applied anywhere. It can be applied on M1, or otherwise sometimes in another problem f of t can be applied on M2. Nothing wrong in that. You can apply wherever you want. That's it. But thing is that, so always you mind it that the second displacement or the second mass element, the displacement of the second mass element is to be considered as your output, and the applied force wherever it is, it could be either on M1 or it could be on either M2 also, it is nothing wrong. So applied force is always to be considered as your input. Therefore output is your displacement, whereas applied force is f of t. Now tell me, what is the transfer function here? Your y of t by f of t, not y1. So don't confuse here, because f of t is applied on this m1, therefore the displacement of is to be considered as well. No, it's not that. So for the given mechanical system, so what the second mass element or sometimes third mass element also to be considered connected with some other problem. Therefore the last displacement, the final displacement, the last displacement is to be considered as your output, and the force element, the applied force, is to be considered as input. Therefore as far as this problem is concerned, y of t by f of t is your transfer function. That ratio we have to find out. Now coming to the solution part, let us quickly see that what are the differential equations, how to write the differential equation for this given problem. Okay, so this is your problem actually. Here, now I can explain you here. Let us carefully follow this. First of all, I already explained in our previous sessions. So for any given, you first write the free body diagram. So how many blocks are there? There are two blocks. Therefore, one by one, we need to draw the free body diagrams. Let us draw the free body diagram for M1. So the free body diagram of M1. The free body diagram of M1. If you write the free body diagram of M1, it shall be like this. So write M1. What are the forces acting on M1? That we have to represent. So obviously, what is your displacement here? Your displacement is given as y1. First you indicate y1. Then you indicate what are the forces acting upon that M1. So first of all, so the force with respect to mass element. Next, the force with respect to K1, that is F suffix K1. And next, the force with respect to F, that is dash pot actually, but in this problem it is represented by F. Sometimes it could also be represented with the letter capital B. Don't confuse. Okay, it can be represented by either capital B or otherwise sometimes small f they will represent. Okay, so here the force with respect to, so F, small f. Okay, don't confuse here. This is the force, this is your dash pot element, and then the common element is also there, that is nothing but your f of k12, means the force with respect to k12, and finally f of t is there. This f of t you represent in forward direction, f of t. So this is your free body diagram of mass element M1. So what are the forces acting upon this mass? So first of all, the mass itself opposes some force. That is what your Fm1, because f of t is applying on this force, on this mass element. Therefore the mass element itself opposes with some force, opposing force. That is what Fm1. And obviously the spring constant will also oppose with some force, and the dash pot element will also have some opposing force, as well as this is the common element, spring element, which is common between M1 and M2, that could also offer some opposing force towards this force actually. All these forces are acting opposite to this f of t. That's why all the opposite force must be equal to your applied force. That is what according to Newton's second law. Okay, now so I will erase this diagram and I will solve here. So now you write according to your second law, Newton's second law, you write one equation now. After that I will draw the free body diagram of M2 and we will solve for that also. So I will erase right now here and just you see. Now according to now according to Newton's second law, then what according to Newton's second law? Your applied force equal to sum of all opposing forces. That is what according to this law. This implies that your input applied force F of t is equal to sum all other, that is nothing but Fm1 plus Fk1 plus Ff plus Fk2 Fk12. This is what that. This is applied force upon the mass element m1. These are the various opposing forces on the mass element towards the applied force. Now, is it not? So now f of t is equal to, now you write corresponding force balance equations. You write corresponding force balance equations. So this is the force opposing by the mass element. Therefore, what is the displacement? Y1. So can you remember that? How the force balance equation comes for this Fm1? Nothing but m1 into d square y1 by dt square. Have you remembered? M1 into d square y1 by dt square plus Fk1. Fk1 is nothing but your spring element. Therefore, it is nothing but K1 into Y1. That's all. Because spring element is opposing force by the spring element is directly proportional to the, what is that? Displacement Y1. So, this is FF dash part is nothing but your F. Don't confuse this is the dash part element constant, not your force, okay? Because as in the given problem they have given you by the letter F, that's why I am using F. Otherwise it could be capital B, okay? It could be capital B or sometimes F also given. Therefore I am treating it as, I am considering as F into d y1 by dt. Okay, always the dash part element, opposing force by the dash part element is directly proportional to the velocity, means dy1 by dt plus, what is the common? Common is nothing but your k12 of, it is displacement y1 minus y2. This is equal to 0. It's not 0 because it is f of t. F of t is equal to. Therefore, this is what your differential equation. Clear? So, applied force f of t is equal to m1 into d square d square y1 by dt square, and fk1 is nothing but k1 into y1. Ff is equal to nothing but f into dy1 by dt, and fk2 is nothing but k12 of y1 minus y2. F of t is, however, it is applied force. So, this is what your differential equation. So, in the given problem, they have asked you to write the differential equation, no? So, this is what your differential equation. You can call it as equation number 1. You can call this equation as by equation number 1. Now, so for this, you have to apply the Laplace transformation here. Okay. Then upon the application of the Laplace, by applying Laplace transformation, by applying Laplace transformation, by applying Laplace transformation to the equation 3, to the above equation 1. Okay, if you apply the Laplace transformation, then how it could be? This implies f of t is equal to capital F of s, because you just draw L of t. By applying Laplace transformation is nothing but you just write that L of t of f of t is equal to L of t of total. That's already we explained. That's why I want to move little bit quick. Therefore, after application of your f of t, it becomes f of s. Then how it could be? It is m1 into, tell me, s square into y1 of s plus, what is this? K1 into your y1 of s plus, what is, it is f, then It is s into first derivative na, d by dt nothing but your first derivative. It is capital S into y1 of s plus it is k12 into what is this, y1 of s minus y2 of s. This is what after application of the Laplace transformation. Okay, from this you just segregate, I mean x y1 of s and then y2 of s values you just take common. So it is f of s is equal to, take y1 of s, so y1 of s if you take common, then from here what is that, m1s square plus, if you take y1 of s here common, then it is k1 plus, it is also y1 of s is there, then f into s. Okay, then here y1 of s is there, just simply you have k12 plus k12. These are what of y1 of s values, and similarly plus, or here it is y2 of s, therefore take minus capital Y2, actually y2 of s, if you take y2 of s, then k12. Is it not? So only y2 of s is this much only, minus y2 of s into k12. This is what your f of s value. This is what your f of s. So give this as equation number 2. Understood? So first what we have done, we have applied we have noted down the differential equation, call it as equation number 1. After that, for that equation, we have applied the Laplace transformation. Then, so after application of the Laplace transformation, your expression becomes like this. And from here, we are separating y1 of s value as well as y2 of s values. We have brought one relationship. So this is your f of s is equal to this much. So call it as equation number 2. Now, go to the free body diagram of second mass element. From also you have to write the differential equation of that second mass element, and from that you apply the Laplace transformation for that, bring some relation, and so we have to substitute some value from that equation to this, and finally you have to obtain the ratio of your what is that, y2 of s by f of s. So now the free body diagram of the second mass element. So coming to the free body diagram of it is free body diagram of M2, you can say M2. So what is there? You draw one block of M2. What is the displacement here? It is y2, is it not? What are the forces acting on this? So M2 itself opposes some force, that is nothing but your Fm2, and the common element is there, it is k12, is it not? Means F suffix k12 you can write. So these are the two forces only acting on this M2 is concerned, but here there is no f of t. F of t will not come here. F of t is acting on your mass element M1, therefore that f of t will not come here. Therefore, as far as your M2 is concerned, you just represent these two forces, the force offered by mass itself, that is what Fm2, and there is a common element, spring element. Okay, now from this you write the equation according to Newton's second law. Now according to Newton's second law, so what is that? So f of t is not here, not there here. Therefore, what is according to second law, Newton's second law? It is Fm2 plus f k12 equal to 0. That's all, because there is no force here, there is no applied force here. That's why it is 0. Therefore, Fm2 plus k12 equal to 0. And from this implies you write the force balance equation. So from this, if you write that, that force is equal to, it is m2 into d square y2 by dt square plus K12. K12 is the spring element. Therefore, it is nothing but K12 into your Y2 minus, because you have to consider the second displacement first, then minus first displacement, because it is common between two displacements Y1 and Y2. So, if you are considering the first mass element, then you have to write for the spring element Y1 minus Y2. And if you consider the second mass element, then you have to write Y2 minus Y1, like that, Y2 minus Y1. This is what your differential equation with respect to the mass element 2. Call it as equation number 3. Call it as equation number 3. This is your differential equation. This is the differential equation with respect to M2. Now, apply the Laplace transformation here. Apply the Laplace transformation here. Then it is M2 into S square. It is Y2 of S plus K12. Let it be like this. Then it is capital Y2 of S minus Y1 of S. Okay, equal to 0 only. 0 only. This is what your actually your equation number 4. This is upon application of your Laplace transformation. This is upon application of Laplace transformation. Now, okay, what is transfer function here? What is the transfer function here? So, what is the second displacement? So, I will, okay, just I will explain you what is transfer function. So, here, okay. So, what is transfer function here? So, your transfer function is equal to, what is the second displacement? I have just in the beginning of this problem, I have explained you that, I already told you that the second displacement, nothing but your y of 2 by f of t. So, that is nothing but Laplace transformation of your y of t. Y of t, is it y of t or y2 of t, okay, y2, nothing but y2 of t, okay, by Laplace transformation of input f of t. This implies transfer function is equal to, what is that? It is y2 of s by capital F of s. This is the ratio we need to find out now. This is the ratio. Okay, for this problem, your transfer function is y2 of s by f of s. You have to find out y2 of s. Therefore, what y2 of s? Therefore, what we can see? So here, if you see the from fourth equation, you write. You can bring some value, either y1 of s or y2 of s, whatever it is. So from here, you can obtain any value. You can obtain the y1 of s value from here, that could be in terms of y2 of s. So you bring from the fourth equation, you brought the value, you find out the value of y1 of s from here, that definitely comes in terms of y2 of s, and substitute the value of y1 of s in equation number 2. Then obviously you substitute that y1 of s here, then obviously that y1 of s shall be in terms of y2 of s. Therefore, here y2 of s will come. Here also y2 of s. Take the common and finally take the ratio y2 of s by f of s. That is your transfer function. So, clear. So, this is what the transfer function. This is y2 of s by f of s. You should remember. Now, so just I will bring y1 of s value from equation number 4. Means that I arrange all these. Okay, so this is also not required for me now. So what I will do now, from this equation, so just you rearrange that. So it is just to segregate, it is m2 s square y2 of s, or otherwise we will do one thing. We take common. You take y2 of s you take y2 of s values. So y2 of s, if you take, it is m2 s square here plus what is this, k12. This is what your y2 of s. Then what is y1 of s? It is minus y1 of s. If you take common, then it is k12 only, equal to 0, no? Therefore, from fourth, just I have rearranged the values of y2 of s and y1 of s. I am separating basically. Now, what you will do? From this, bring the value of y1 of s. This is nothing but y2 of s into m2 s square plus k12. It is minus term. Take all these to the right hand side, or that becomes equal to y1 of s into k12. Is it not? This implies, write the value of y1 of s. If you write the y1 of s, then k12, whatever is there, it comes to the by here. By k12 comes here, means y1 of s equal to, so it comes to the denominator here, means y2 of s bracket, this will be there as it is, m2 s square plus k12, and it comes here, k12 comes here. Is it not? This is what your y1 of s. Well, it is something, you can call it as some equation number 5. Now, what we should do? Substitute this y1 of s value. Now, substitute this y1 of s value is this much. Your y1 of s is in terms of y2 of s. Now, remember that. Your y1 of s value is in terms of y2 of s. Therefore, you substitute this y1 of s value, hai na? So, this value y1 of s is equal to, you substitute here. So, y1 of s is equal to this much. So, therefore, in the second equation, you have y1 of s here. So, substitute this y1 of s equal to this much. This entire thing you substitute here. Then, y2 of s is already there. y2 of s is something will come here, and already y2 of s is there. So, from these two, take y2 of s as common, and something will come in the bracket. Then take the ratio of y2 of s by f of s. Then you will get the transfer function. Therefore, now what I will do? So, I will substitute this y1 of s value. y1 of s is equal to this much. I will substitute here. Therefore, what it will come? Let us see. Let us see. So, then obviously your f of s equal to, from second equation, you can write from equation 2. From equation 2, because in equation 2 only I am going to substitute that. From equation 2, your f of s equal to, is it not? F of s equal. Now, what is your y1 of s? y1 of s is nothing but this one, this entire, means you write here. The same I will write again. y2 of s bracket m2 s square plus k12 by, it is k12. This is what your y1 of s. So, here the bracket will come, means this bracket. Again you write all these, m1 s square plus k1 plus k12 plus f into s. This is what? Minus y2 of s into k12. That's all. This is what your equation. I have substituted already, so that y1 of s into this equation. So, from this implies what we will do? F of s equal to, your f of s equal to, take y2 of s as common, because this is total one product and this is another term. This is total one term, this is another term. So here y2 of s is there, here also y2 of s is there. So take y2 of s as common. If you take the y2 of s as common, what you will have? All this is multiplication, no? So means that you write m2 s square plus k12. Definitely you should keep in bracket here. And again this also, it is m1 s square second term, then you write f into s first. It is good to write like that. And plus it is k1 plus k2, again it is a constant, then keep in bracket because it is a total or the constant, spring constant, that's why. And your bracket closes here. This is big bracket and this is another bracket by your k12. Okay, so here it comes already, you have minus, already y2 of s we have taken common, then it is k12. That's all. That's all. That's all. Okay, then you can further simplify, no problem. So this is a little bit mathematical thing, simplification basically. And finally you can write the transfer function, or you can leave here also, means by giving the ratio of y2 of s by, it is y2 of s by your f of s. This is what finally the transfer function means, y2 of s by f of s, means the entire you should bring to the another side, and therefore y2 of s by f of s is nothing but total. This comes 1 by, it goes to other side, no? Therefore it comes 1 by 1 by, okay, 1 by. So you write the total, means it is m2 s square k12 m1 s square fs plus k1 k12, okay, by k12 minus k12. This is what I think you can, or further you can simplify this also, no problem. Almost all we reached the answer. This is your final, and simply it is a simplification only. Take the LCM. If you take the LCM part, then obviously k12 comes, it comes to here actually, okay. Okay, then definitely the remaining part, it will comes denominator part only, is it not? So this is the simple this thing you can write, okay. So it is a simple mathematical thing only, okay. So otherwise you can write, no problem in this. It is a simple mathematical simplification only. Finally already this much is enough, or otherwise finally you can write this also. Transfer function is equal to your y2 of s by f of s is equal to, so then obviously it is something by something is there. Therefore obviously if you simplify this and you take the LCM part and finally the denominator comes, if you change that na, so k12 comes like that only, and the remaining part everything comes here only. It is m2 s square plus k12. This is in bracket as it is. This will come as it is, nothing wrong in that. m1 s square plus fs plus your product k1 plus k12 minus, actually it is k12 into k12. I mean definitely it comes like this only, is it not? If you take the LCM, then actually comes by k12, but that k12 I already mentioned in numerator. This is your final equation. Likewise, this is your final equation. Okay, So it involves little bit mathematical related simplification. Simply you have to substitute one equation in the second equation. Either you can, I have brought for equation x1 of s, that is in terms of x2 of s. You can also brought for you can also solve for x2 of s, but obviously don't forget that your transfer function is x2 of s by your I mean f of s only. So finally you have to bring that relation. Okay, that ratio you should bring. For that, what need to be done? Like that, you have to obtain the value of x1 of s and substitute in that. Finally, we will get this. So this is what your transfer function. So dear friends, so with that, I just want to finish this our today's lecture 21. I think you have enjoyed this, and this is very widely used. I mean, asked question in your academics especially, and then this can be also asked one time in UPSC IAS examination, is it not? So practice it, and you will definitely I mean get the confidence in solving such type of problems. Okay, so with that I would like to close today's presentation, and I request you all to comment on this, and if you need any I mean doubts and comments or whatever it is, don't forget to give feedback and to comment on my channel. And please, if you like it, definitely I request you all to like and then to share with your friends. Don't forget to share with your friends. Never forget. Please share to your friends and help your friends, especially those who are unable to go to colleges and unable to understand the subjects. For them, actually, I mean to reach the very poor students also. It has to reach very average students and poor students, that you all should excel in our career. You should all I mean should come up, you should grow, you should know. That's what my intention of presenting all these videos for you all. Therefore, all the best and good luck. Thank you one and all.